Alright, what's up everyone? Welcome back to my channel, TigerTeel. Obviously you can tell the teal part right here, my last name. I've been in the United States Air Force for going on 8 years. It's crazy, time has flown by. If you're in the service, you know that you gain a lot of camaraderie with a lot of people, take the good with the bad, and you notice that time just goes by a lot quicker than what you'd ever think. So, a lot of people have asked about my training that I went to for the 2 weeks that I was out in Missouri and away from YouTube and content creation. So I'm going to tell you a little bit about my job, what it means to me, what I do in it, and a little bit about what our training was. I can't go into too much detail because there's test compromise and all that fun stuff in case someone that's going through it later will go through. There's a whole big thing, and I just don't want to, put myself into that situation. So, what do I do in the Air Force? I am a 3 Echo 5 engineer. So 3E5 is our Air Force specialty code. It means that we are support, which is a 3, E for engineering, and then 5 is just the RIP that we fell under. Someone can correct me if I said that wrong, but you can Google what AFSC means, Air Force Specialty Code. And like I said, I am in engineering, so that means we do construction management all the way from the planning and programming to the execution and design, all the way to the inspection at the end. And then we hand it off to contracting and they take the rest of it. We also do maps. We will build base maps for installations, we will build area maps, and we make the accurate depiction of what each installation looks like and future plans, legacy plans, and shows the changes of everything over the years with construction projects, whether it's military construction, aka MilCon, or if it's by outside contractors, which we have a lot. I can't give you exact, because I don't know. All right, so what do I do specifically? Well, I am on orders with the Base Honor Guard. And that means that I deal with funerals every day, pretty much. We have people dying, unfortunately, every day, and that means that there's a service every day. And we will go and provide military honors, which is at least 2 people. One will play taps, which is on the bugle. If you haven't heard it, please look it up on YouTube. You're already here, so why not? The other is we will fold a flag, the American flag typically, unless the member is from another country, if they are being buried here. As long as they have honorable service in the United States Air Force, we will perform honors, and Space Force. Because so far Space Force does not have their own honor guard, and they are still a department of the Air Force, therefore we will also cover Space Force. Now, back to the 3 Echo 5 engineering. What did I do over those 2 weeks? We recovered soil sieve analysis. So you take a big old sample of dirt from a spot that you are trying to build at. Dirt meaning anything from the sublayer all the way down to base rock, or bedrock, sorry. Bedrock being the impenetrable surface in the earth. Impenetrable being a statement there. Now, if you play Minecraft, you will know exactly what bedrock is. So anything above bedrock is dirt. However, so what the sieve analysis does, or soil analysis does, is we get to determine what kind of soil it is. We have multiple different ones. Off the top of my head, it's sand, silt, and clays, right? And gravels. Anything that is maintained on the top, which is our largest one, I believe it's an inch in diameter, or inch squares, is considered a gravel. Going down further, there's a whole flow chart for this, and I might put this up on the screen if I remember, at 4 minutes and 47 seconds. So if I remember, it'll be here on the screen, or it was here on the screen, depending on where you're at in the video. And then from there, we have other tests like a ribbon test where we put water in the sand or the very, very fine grains that we have. They're called fines. They're what's retained at the very bottom of the sieve analysis. And this is to measure the plasticity index. So how much plastic is it? How much can we mold this to where it doesn't break before we can get it to where we really need it? This also allows us to see how much water it can hold, how much water it needs to hold, how much water. It's all about water and all about how well we can actually put a structure on this certain site. Now, do you think that in the desert where it's nothing but sand, that it's a good place for construction? No. There's multiple reasons for this. One, because sand is not very load compacting. It does not compact without a lot of water, and even after it dries out, guess what? That's going to crumble and break. And that's something that you're going to know with the sieve analysis, along with other plasticity index charts, learning about the water, etc. Now, there are a lot more tests that we do for soil. I'm not going to go too completely into those. It's kind of in depth. Maybe I'll do a later video on that. I am by no means an expert in this field. I don't do it every day, nor do I do it like once a year. It's a rarity for me because I am in the reserves, which means it's 1 week in a month, 2 weeks out of the year. So if we get to do it, we get to do it. If we don't, we're not going to. So on deployments, if you work with, we have Red Horse and Prime Beef. Red Horse is more of our construction team for new builds and demolishing structures, where we have Prime Beef is more of the maintainers and construction management for new builds. Red Horse is really the military construction. Prime Beef is more maintenance and the contractor side. So, what's another thing that we covered? Another thing we covered is concrete. You see buildings everywhere that have foundations. We have to know what foundations are going to be best and how deep we need to make the footings on those foundations and how strong we need to make this concrete. Where do we get this information? Well, we use the IBC, International Building Code. We get to see every piece of information, and guess what? That's public knowledge. You can search the IBC. You may have no clue what you're reading, but you at least know the ASTMs. I can't remember what it even stands for, so I'm not even going to attempt it. But we know all the rules, laws, and regulations for every building code, every structure that can be put up, whether it's a mobile home, whether it's a manufactured home, or even single and multifamily home, all the way up to a large factory and more, right? Including airfields and shelters, right? All right, so concrete tests, we get to know slump tests, where we take it straight out of the truck, put it in this upside down cone, do 3 layers of, I want to say it's 25 rods. We have a rod. I'm not going to show you the rod, and I'm not even going to show you the motion, because everyone's going to be like, oh my god, he's doing a certain motion, and I'm going to get freaking roasted here. Well, so that is to measure and see how the slump is. A slump means we need to either add water or take water out of the mixture, which sucks, because if there's not enough slump, then, well, it needs to dry out, which means it needs to sit there and rotate for at least, I'm not even going to give a time frame. Again, I'm not an expert on this. And then if it's got not enough water, then they can just squirt some water in it and have some fun, right? We'll take another slump again before they lay it. As engineers, not as contracting, we cannot turn a truck away. If they come in with shit concrete and they want to put out shit concrete, they can do it. But if the building comes back wrong, it's up to contracting what they want to do with that. Again, we have no legal binding to the contract. Sorry, get tongue-tied sometime. That's just me. So all we do is go off of a thing called a SAL. We have thing called a SAL. It's called the Statement of Work, and this tells us exactly what specifications each project needs to do, the timeline, how they need to do it, what they need to do, and what materials they can do it with. Now, again, we do daily logs, so we will log anything that's wrong. We usually do a public courtesy to let the contractor or whoever's doing the work know. If it's a contractor, again, we can't tell them to redo something. We can recommend it, but we have to go through contracting. And again, I'm not contracting, so I can't tell you any of the logistics or ins and outs of that. So I'll let someone else that is contracting do that. However, as our job, we just need to know the entire thing through and through. We have to have knowledge in this thing so that we can give the mission of an engineer is to provide quality work for the government, by the government, to keep the mission going. All right. So now that that little tangent's done, concrete goes in multiple different tests. We have slump tests. We have cylinder break tests, those are awesome. If I can find a video of one on my phone from deployment, I will gladly throw it up here. If I can't, unfortunately, I'm just saying this for no reason, and we're going to continue on. But what you do is you'll take a sample for 7, 14, I can't remember, but then 28 days is the very last one that I remember, right? You can do up to 12 samples, or yeah, so 4 samples times 3, so you have 3 7s, 3 14s, and 3 28s, or whatever. You'll take these, once they're done curing, you'll cure them by either doing field cure, where you leave them out in the field for those amounts of days in a cooler, or you'll bring them back to the lab and lab cure them in a bath of a certain chemical that takes out the water, blah, 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 and lets it just cure. Then you'll take a cylinder press, or whatever the hell it's called, hydraulic press. You'll put the cylinders in it, put some pressure on it at a certain amount, and once it breaks, this machine, certain machines that we use will stop automatically, go back up, and we'll record what kind of break it is, because that determines the structural integrity of this concrete cylinder, and it'll tell us at what point it broke. So airfields, typical, it needs around 6,000 pounds of pressure that it can withstand at any one point at any time. Typically, your foundation should be around 2,000 to 4,000. I know it's a wide range, but that's what they give us. All right, then we have we have beams, structural beams. They're concretes. We cast them, and we also do the same amount of day tests as the cylinders, and those are kind of cool too. But then you have to take out, in these machines, there's a small circle at the bottom. Take those out, put the beam press in, and see where it breaks. And if it cracks outside of a certain zone, it's no good. Gotta take the concrete up and redo it. So after concrete, we go into asphalt. Asphalt testing, I will not lie to you. Don't know shit about it, other than it has to be a certain temperature whenever it comes out. It has to be a certain temperature after about an hour. Other than that, I can't tell you much about it, because I haven't done but one job with it to where I inspected it, and that was it. And all I did was shoot a heat gun at it. That's it. Not a real gun, a heat gun where I'm telling the temperature. That's it. And that project was super quick. Long hours, but it was done within a week. I'll just tell you that. All right, so what else do? We do construction management. Like I told you, we're bound to a SAL. We get a statement of work off the rip. It tells us the requirements of the job, the timeline that we have to meet, the bill of materials, which means what they are bringing in. It's typically the contractors, whenever they submit their bids, will also submit a drawing of the project. what materials are going to bring, and the timeline. So that's where we get all those. Statement of work also can come from them, or it's rewritten by one of our engineering leads, not myself. I can write a SAL. I've been to the class, but I'm not going into it. All right. From construction management, like I said, we do a Air Force. I want to say it's 101. I could be wrong. That's the form that we go and we do daily field reports. Like I said, if there's any discrepancy, we can let the contractor know. However, we have to go through contracting to do everything else. They have to be they're the approving authority. We are absolutely not. We don't touch the money. We just inspect the work and try and meet it to a certain standard. And then from there, we have work clearance requests, also known as a dig permit. However, it does not have to be digging. We don't have to dig for every project, nor do we have to have, but we do have to have a work clearance request for every project. That's a Form 322, I want to say. We also have other ones, certain like burn permits, etc. Not going to go into them. You don't need to know all the forms. I don't personally remember all the forms, but like 1391 is one. Can I tell you what that is? No, but I have a notebook that has it all because I wrote down the notes. All right. So what we do on a construction site is, one, maintain safety. If it says they have to have hard hats, they have to have hard hats, and we will stop construction until they have hard hats. If that slows them down, well, we're going to tell contracting exactly why that slowed them down and why we stopped the project, because we are allowed to stop it for safety. If it can cause harm to an individual or property, we can stop it. We can cease it until that is remedied. All right, we will take photos. We document everything. Like I said, the Air Force 101, and then photos. And then we will go back just to make sure everything's online and give a briefing to our leadership. As an NCO, typically in the construction management side, which is where I have most of my experience, along with the designing side, which we'll get into here in a minute. So, yes, as an NCO, non-commissioned officer, if you're not in the military, it's E5 through E7, or E6. So once you get to E7 and above, then you're a senior NCO. Then you have officers, and that's a whole different ranking system, and you don't care about it right now. You're in charge of making sure everything goes seamlessly. Now, will anything go seamlessly? Absolutely not. There will always be at least one mistake, and as long as you catch that one mistake and you know how to remedy it, or at least provide a decent resolution for it, that's what you can do. That's perfect. You've done it. So, my training that I went to has already been covered. That's what all that was about. So now we're going to get into other parts of being a 3 Echo 5. Engineering, again. AFSC, title is engineering. I'm engineering journeyman. I'm going on completing my 7 level. I have another class to take, not in person, online, all the fun stuff through Air Force Institute of Technology. All right, we're going into the map making. Like I said, we make installation pictures to show legacy, future, and current status of a base or installation or area around us. Typically, if you want to know who does this, it's usually your state departments, like Department of Transportation, Medicaid, etc., like that. It's bare bones. You can literally go to Google and hit the terrain, not even the satellite images. Some of them have satellite images, but we're not going to go that far. It's going to show how where the roads are, utilities, buildings, POIs, sidewalks, stuff like that. That's it. It's map making. We will literally build a map, print it out, laminate it, do whatever we need to do, and that's another part of our job. The other part of our job is drafting. We use AutoCAD. Yes, we can hand draft. We haven't done that for years, but technology fails. We all love it, but it's not 100% certain. We have AI, cool. We can, hell, if we wanted to, we can write a code and have it drawn. But we use AutoCAD. Transitioning probably to Revit in 10 years, but don't like quote me on that. Like I said, 10 years, I might not even be in the Air Force by then. I'll be at 18 years if I am. But AutoCAD, you set up CAD layers. We're going to put up, again, I was telling you about the concrete. We need to know how deep those footers need to go. If you've ever seen a blueprint, whether you've played City Skylines or interior decorator, you watch, what is it, home renovation shows, stuff like that, they're looking at blueprints. Guess what? Those were drawn by engineers and architects. All right. We will draw electrical plans. This shows every outlet in the house, every wire that's in the house, every light in the house, ceiling fan that you can't see that's above me. It shows where the wires go, what switch the wires connect to what light or what outlet. It shows ground fault indicator outlets beside in the bathrooms, right, or latrines as we call them. We have the sinks, water closets for mechanical. I mean, we draw literally almost down to the exact specification of the room. Like, this outlet is 6 feet from this outlet. This outlet needs a minimum standoff distance of 12 feet, or so on and so forth. Those are not exact. I'm not reading the IBM, nor do I remember it all off the top of my head. However, we have to draw it to the standard. That way, whenever the construction goes up, then it is done to the standard. Because whenever we print off our drawings, guess what? Structures uses it, HVAC uses it, heating, ventilation, and cooling, if you don't know what HVAC means. Electrical uses it, heavy uses it. So like I said, blueprints and drawings, that's the drafting. We have to draw a site plan. It's simple. It's not simple, but it's simple. It's simple to understand, not so simple to do unless you've done it for a while. And it's always changing, just like the medical field. Engineering is always changing because codes are always being updated because something has been found faulty, which means it needs to change, which is good. Change is good sometimes. Change is good most of the time. So we have one more aspect of my job, and that's surveying. Surveying is where you see the guys out on the highway. You're like, oh my God, why is this construction taking so long? Well, they're usually using GPS now. It used to be auto levels were the thing. Auto level is a like monocular looking deal that you take fillet rods, which have certain measurements on, and you look down that auto level and you get your reading. Then you look back, you look at that one. If it's got the same reading as its same elevation, that's what the auto level's for, is to see if the elevation changes from a certain point. And then we have a total station. This is more of your automated auto level. It'll shoot a laser at a prism and bring back. This has to also be corrected by human error, light refraction. Light refraction. If it's a misty morning, I guarantee your laser is going to be off at least a degree. We do calculations to degrees, minutes, seconds off of angles. It's crazy. That's how an angle is formed, but it's degrees, minutes, seconds. Just like a clock. You think of a clock at what? To me, okay, so what you can see is 3 o'clock. What I can see is 6 because mirrored image. It's a certain degree, minute, second. The angle, the right angle is at 90 degrees, 0 minutes, 0 seconds. That's a perfect right angle. Will you ever get a perfect right angle in construction? Probably not. But the auto level helps. And this, actually the total station helps. Let me correct myself. Total station will help because it's a robot that does it for you. You tell it to turn 90 degrees and guess what? It turns 90 degrees. And then we have GPS that utilizes obviously global positioning systems to give you exact coordinates of where you're at as long as you tell it where you're at. You can do, gosh, you can cook the base station for a while and let it sit in one spot for over 24 hours, and it will give you probably the most accurate position of that total station or of that home base station down to the nearest degree within a 1% fail rate. So that's a lot of our job. What we do with surveying is we lay out the site. Then whenever heavy comes in to cut out the crap or lay concrete, we have to tell them exactly where they're at on elevation. Because guess what? If their elevation and grade is off, this is either going to be a hilly building, it's going to be up on a slope where it's not even level. It's just not good. So the importance of our job is super high. And whenever people ask us what the job, or ask me what my job is, I'm like, I'm the person that everyone loves to hate because I will tell you exactly what you need to do and how you need to do it. And if it's wrong, I'll tell you to redo it, but I will not be doing your job. And so it's like, oh, this is some dude in the office that's telling us how to do our job that doesn't know our job. But I can guarantee you, out of majority of them, minus EM, operations, and electrical, I guarantee you, and maybe Power Pro, if you give us 2 days, engineers or 3 Echo 5s can learn your job within 2 days, where you would have to take 4 months to learn ours. Now, it sounds egotistical, but you have to have a certain ASVAB score to hit our career field to get it to be one of your choices. Luckily, I did well in everything but freaking general. I got a 48 in general, if you wanted to know. Yeah. Common sense may not be there. I try to be pretty common sense, or have a lot of common sense, but I'm pretty book smart. Socially, I'm pretty dumb. I'm not going to say the R word because that's offensive. But yeah, if you want to know more about our job, type in Google 3E5X1 Air Force, and it'll tell you everything about it. It's public knowledge. It's no secret. We get to have fun. We are, augmentees for security forces sometimes if they need them, so we have to qualify every year for M4, and the officers get to do M9, senior NCOs get to do M9, so pistols, but we qualify with the rifles every year. So yeah, if you have questions, drop them in the comments. If you like this video, make sure to give me a thumbs up and share it with your friends. I mean, again, maybe not all of this is 100% correct. I'm not perfect, nor do I know every little bit about my job. I am a SME in certain parts of my job, i.e. construction management and drafting and design. But I'm not going to know everything about everything. Alright, I may know everything about, or I may know more than 90% about one subject of my job, but I will not know everything about everything. Again, this is constantly changing. And make sure you check out one of these 2 videos. If you like my channel, here it is below. Have fun, y'all.